Welcome friends, I am Rajendra. Welcome you once again in my next lecture. Chapter name is complex number, but the next topic is logarithm of a complex number. So let's start with logarithm of a complex number. So friends, let's consider z equals to x plus iy, or in exponential form we can write z equals to r e raised to I theta, right? So if we're taking logarithm on both sides of the above equation with respect to base e, then we get ln of z is equal to ln of r e raised to I theta, right? Then let ln of z equals to p. If you consider that, then we get p equals to ln of r plus ln of e raised to I theta, right? Now if we apply logarithm to exponential function, then this e base goes down and remains only I theta. So next step is ln of p equals to ln of r plus I theta. Now here theta has infinite number of values, all differing by multiple of 2 pi, and therefore complex number p equals to ln of z has infinitely many logarithms differing from each other by the multiple of twice pi. Okay, then next topic is trigonometric functions. Friends, we are aware of these trigonometric functions from the 9th standard, right? So here from Euler's formula we know that e raised to I theta equals to cos of theta plus I sin of theta. We can call this equation as a equation 1. Okay, now if we replace theta by minus theta in this above equation, we get e raised to minus I theta equals to cos of minus theta plus I sin of minus theta, right friends? But we know that in trigonometric relations, cos of minus theta is cos of theta and sin of minus theta is minus sin of theta, right? By using these terms in previous equation, we get e raised to minus I theta equals to cos of theta minus I sin of theta. So this equation is second, we can call it as. Now step by step, adding equation 1 and 2, we get, by addition of equation this 1 and 2, we get cos of theta equals to e raised to I theta plus e raised to minus I theta divided by 2. This equation is known as equation 3rd. Okay, we nominate it. Then next, subtracting equation 2nd from 1, then we get sin of theta equals to e raised to I theta minus e raised to minus I theta divided by twice I. This equation we can call it as equation 4. Okay, now friends, using above relations we can obtain other terms as follows. Now we know that sec theta, other trigonometric term, sec theta is equal to 2 divided by e raised to I theta plus e raised to minus I theta. Now tan of theta, what is exactly tan of theta? We know sin of theta divided by cos of theta. By putting that terms, we get e raised to I theta minus e raised to minus I theta divided by e raised to I theta plus e raised to minus I theta. Okay, the next cos theta equals to, this is inverse of sine, right? So this get numerator get denominator and denominator get numerator. So here cosec theta is equals to 2i divided by e raised to I theta minus e raised to minus I theta. Similar manner, cot of theta can be calculated like this. Now similarly, if we replace real theta by complex z, we know that friends from starting we are talking about the complex number, right? So if we replace real part theta by the complex part z, then we get different relations of sine of z, cos of z, etc. For example, I can draw sine of z, that is equal to, just we have to replace the theta by complex z. Okay, so sine of z is equal to e raised to iz minus e raised to minus iz divided by twice I. Okay, then next is hyperbolic function. Now hyperbolic function means what? Now friends, we have already shown in previous slide sine of z is equal to, that means we have replaced real theta by complex z. Okay, sine of z was e raised to iz minus e raised to minus iz divided by twice I, and cos of z can be determined e raised to iz plus e raised to minus iz divided by twice. Okay, so this equation may be called as 5. Then if complex number z is purely imaginary, what? Complex number z is purely imaginary with its real part 0, then z equals to iy. Now using this equation in equation 5, we use this equation 5, then we get sine of iy. What we have to replace? Z equals to iy. Okay, so sine of iy equals to e raised to minus y minus e raised to y. That gives sine of iy equals to, I becomes common, into bracket e raised to y minus e raised to minus y divided by 2. Now call it as equation 6. Similarly, cos of iy equals to e raised to minus y plus e raised to y divided by 2. That gives cos of iy equals to e raised to y plus e raised to minus y divided by 2. Call it as equation 7. Now these functions are called as hyperbolic functions. Okay, and indicated as sine of h or cos of h, etc. Okay, so can we write sine of hyperbolic z equals to e raised to z minus e raised to minus z divided by 2, and cos of hyperbolic z equals to e raised to z plus e raised to minus z divided by 2. Okay, then other hyperbolic functions defined in similar manner parallel to trigonometric functions, that is tan of hyperbolic z equals to sine of hyperbolic z divided by cos of hyperbolic z. Okay, similarly cot of hz, cosec of hz, sec of hyperbolic z, same terms can be determined with the help of this terminology. Okay, so these all functions are known as hyperbolic functions. Okay, now there are some other important identities are there. First, sine of hyperbolic I theta equals to I sine theta. Then friends, we have the relation sine of z equals to e raised to z minus e raised to minus z divided by 2. Now using z equals to I theta in this relation, we get sine h of I theta equals to e raised to I theta minus e raised to minus I theta divided by 2. Now if we multiply and divide it by I, okay, multiply and divided by I, then we get I into inside bracket e raised to I theta minus e raised to minus I theta divided by twice I. That is known as, and this is the term of sine of theta. Okay, so we can write it as left hand side equals to right hand side, that is sine of h of I theta equals to I sine of theta. Okay, next identity, cos of hyperbolic I theta equals to cos of theta. We have the relation, friends, cos of h z equals to e raised to z plus e raised to minus z divided by 2. Same as previous identity, we have to just replace z equals to I theta in this relation. Then we get cos of h I theta equals to e raised to I theta plus e raised to minus I theta divided by 2. Therefore, we can write it as cos of h I theta is equal to cos of theta. So friends, these are two identities of complex number. बाकी अदर आयडेंटिटीज ते आपण नेक्स्ट लेक्चरला बघणार आहोत. सो या लेक्चरसाठी एवढं सफिशियंट. थँक्यू.